So if you turn to page 40, we're going to go over how to determine if something is a difference of squares. Now, difference of squares is a binomial connected with a subtraction sign where the first term and the second term are both perfect squares. So, to be the difference of squares, it must be a binomial, must be two terms. It must be connected with subtraction, and it must have two perfect squares. Okay, so we're just going to go over a few of these and say, are these difference of squares? Now, number one, obviously not difference of squares. Why? Because it's a trinomial. Number two, okay, it's a binomial. That's good. Okay, it's connected by subtraction. That's good. But 7 is not a perfect square, so this is not the difference of squares. Look at number 3. First term is a perfect square. Last term is a perfect square. It's only two terms, and it's connected by subtraction. Number 3 is the difference of squares. Number 4, that's not the difference of squares because it's added. That is the sum of squares. We don't have a special rule for that. Number 5, that is the difference of squares. It's a binomial connected by subtraction where the first term is a perfect square and the second term is a perfect square. And number 6 is also the difference of squares because the first term is a perfect square and the last term is a perfect square. Some of you may say, but why did the 6th isn't a perfect square? And then I would remind you that y cubed times y cubed is y to the 6th. Okay, so now that we can recognize the difference of squares, I will teach you how to factor the difference of squares. So, if we look at number 1, okay, number 1 says m squared minus 81. Perfect square, subtraction. To factor it, take the square root of the first minus square root of the second times square root of the first plus the square root of the second. Okay, number 2, x squared minus 25. Again, square root of the first minus the square root of the second times the square root of the first plus the square root of the second. Number 3, a squared minus 11. Okay, that becomes 121. That becomes a minus 11 times a plus 11. Okay, now let's try the ones at the bottom of page 40. So 16x squared minus 25y squared, 4x minus 5y times 4x plus 5y. Then we have 81x squared minus 16y squared, square root of the first minus square root of the second times square root of the first plus square root of the second. Then we have 16x squared minus y to the fourth. That becomes 4x minus y squared, 4x plus y squared. Okay? And now let's look at the last one. Last one is 16x to the fourth minus y to the fourth. Okay? That becomes 4x squared minus y squared times 4x squared plus y squared. But we're not done because I have to look at each binomial and make sure it's fully factored and also not another difference of squares. And look, this is another difference of squares. So this becomes 2x minus y, 2x plus y. So should I also make this 2x minus y, 2x plus y? The answer is no, because this is not the difference of squares. It is the sum of squares and therefore not factorable. Okay, so that is a short lesson on the difference of squares. Now, I'd like everyone to turn to page 45, and we're going to do another short lesson on how to recognize a perfect square trinomial. Okay? So page 45. Now, a perfect square trinomial, here, we'll look right here. Let me just make this bigger. Okay, to be a perfect square trinomial, your first and third terms must be perfect squares. And your middle term must be plus or minus 2 times the square root of the first times the square root of the third. Now that sounds a little confusing, but let's look. 4y squared is a perfect square. 81z squared is a perfect square. So this will be a perfect square trinomial if I take the square root of the first, which is 2y, multiply it by the square root of the last, which is 9z, and that becomes 18yz. And then double it, I get 36yz. So it was twice the square root of the first times the square root of the last. Let's try the next one. This is a perfect square. This is a perfect square. Square root of the first is 4a. Square root of the last is 7. 4a times 7 is 28a. Double it, I get 56a. Let's look at this one. 4a squared. Square root is 2a. Square root of this is 5. 2a times 5 is 10a. Double it, we get 20a. 9a squared minus 12a plus 4. The square root of this is 3a times 2 is 6a times, 3a times 2 is 6a. Double it, negative 6a. Okay? So if we look at this last one, why is this not a perfect square trinomial? And the reason is, to be a perfect square trinomial, that last term must be positive. Okay, so let's try to do a few of these. Let's look at the first one. We have x squared minus 16x plus 64. Okay, so the first term is a perfect square. So I take the square root of the first, sine of the middle, square root of the last, and square it. And you are done factoring it. Now let's make sure this works. Negative 8 times x doubled is negative 16x. So this is definitely a perfect square trinomial. Let's try the next one. 4y squared minus 12y plus 9. Okay, first term is a perfect square, last term is a perfect square. Square root of the first is 2y, sine of the middle, square root of the last. 2y times negative 3 is negative 6y, double it is negative 12y. Okay, let's look at 9s squared plus 6st plus t squared. Square root of the first is 3s, sine of the middle is plus, square root of the last is t. 3s times t is 3st, double it, 6st. Okay, now the last one, negative 3z squared plus 24z minus 48. And you may say, that's not a perfect square trinomial, and you would be right. But can I factor out a negative 3? Yes, I can. So if I take out a negative 3, I get negative 8z plus 16. And now this, square root of the first, sine of the middle, square root of the last. 4 times z is negative 4z, double it, negative 8z. Okay? Now, you can try the checkpoints 5, 6, 7, 8 on your own. And I want you to look at the very bottom of the page where it says, determine what values of k make 25x squared plus kx plus 49 a perfect square trinomial. Okay, so I know this term, k. K must equal 2 times the square root of the first times the square root of the last, or negative 2 times the square root of the first times the square root, of the last. So k would either equal plus or minus 2 times 5 times 7, so k would equal plus or minus 70. Because that middle term could be positive or negative. That's the end of this video.